Let's look at one final example. So you and your friend each have accounts that earn annual interest that's compounded continuously. Remember that compounded continuously means that we're going to be using our compound interest with our E equation. A equals P times E raised to the RT power. The balance A in dollars of your account after T years can be modeled by A is equal to 1,400 E raised to the 0.04T. The graph shows the balance of your friend's account over time. So we have an equation for yours, a graph for your friend's. We want to know which account has the greater principal or initial value, and then which has a greater balance after 10 years. Let's start by looking at our principal or our initial value. And so let's identify yours and your friends. So remember that our principal value, our P, is the number in front of E right here. So that's $4,500. And that occurs at a value of T equals 0. So if T is 0, this entire part becomes a 1 and we have 4,500. Looking at the graph, we can look at a time of 0 and see what our principal amount is, and it's 4,000. So you start out with more principal, $4,500. Now let's look after 10 years. Again, let's talk about yours. And we can just plug into the equation with a T value of 10. So 4,500 times E raised to the 0.04 times 10 power. And this is going to be equal to $6,300 about, but we'll say 6313.21 just to get really precise. Now, let's figure out what your friend has. And so at 10 years, we want to come over here to 10 and then go up till we reach our graph, and it's a little over 7,000. I'm going to call it somewhere about $7,200. Even if we'd said it was exactly 7,000, but I can tell it's a little higher, your friend has a greater amount at the end of 10 years.